Now that we've gotten used to identifying our null and alternative hypothesis, it's time to actually run some experiments, and that is actually test some hypothesis. So what we need to do is identify our critical region. And we also need to realize that when we are doing a hypothesis test, we are looking at the alternative hypothesis, the one that has the not equal. And we're going to see if that alternative hypothesis falls within the critical region. So there are three possibilities as far as when we're writing our alternative hypothesis. We could have the claim, or it's not necessarily the claim, but we could be saying that our mean is less than a certain value, not equal to a certain value, or greater than a certain value. So if it's less than, we're going to use a left-hand tail test. So which means I would have my normal, and the left tail would be over here, which means when I do my inverse norm, say I'm doing with an example of 5% significance, then I would do an inverse normal of 0.05, and that will give me the z-score for right here for a 5% significance level. Now, if I'm doing the testing, if the average is in the middle of something or not equal to something, I'm going to use a two-tail test or a central test. And that's kind of deceptive the way I worded it there, central, because I'm actually looking at the tail ends, both tail ends. So let's say I'm doing a 5% significance again. I'm going to need to know this z value and this z value. Now, I think the easiest way to do this is to go into your stats menu and set your mean equal to 0, your standard deviation equal to 1, and then go ahead and put in an area of, if you want 5% significance, then you're going to put in actually an area of 95%, and that's going to represent actually this area in here. And you're going to select central. And that gives you this area in here. And what we're going to want to do then is it will give you the two z-scores right here. You could alternatively take that 5% significance and split it into two halves, 2.5 each, and inverse norm the 2.5. And if you inverse norm that, that'd be 0.025. That would give you this z-score right here. And then just switch it to positive, and that gives you the one on this side. So we would then be looking for if our HA falls into that region. Now, if we're doing HA is greater than a value, we're going to do a right-hand tail test, which means that we'd be looking right here. And if we were doing again, a 5% significance level, we would be doing, we could, on our calculator, set our mean equal to 0, our standard deviation equal to 1, and we could find an area. Well, we want this area over here on the right, so that's going to be 5%, so 5%, which is going to be 0.05. So over here, this should have been 0.95. And then we would select a right tail, and that will give us the z-score right here. Or alternatively, we could inverse norm, and if we want 5% significance right there, we could inverse norm 0.95, and that will just give us it gives us the same thing. So kind of confusing. You need to know how to use your calculator. So let's take a look at what we would do. So we need those inverse norms gives us the z-score for the critical region of one of our tests, but we need to know the z-score for our hypothesis or our alternative hypothesis. So we are actually going to use this formula right here. Now this is our z-test, and we can only use the z-test if our sample size has to be bigger than 30. If it's not bigger than 30, then the z-test actually is not going to work, and we'd have to use something called the t-distribution. But for most of what we're doing right now, the z-test will be fine. But be looking for that. Your sample size does need to be bigger than 30. So here's our z-score formula. Now, remember, our actual z-score formula would be x minus the mean all over the standard deviation. So it has been changed a little bit. So this x bar, what is that? This x bar is our sample mean. And this mu, well, what is that representing then? Well, this is representing our claim about the population mean. So rather than coming up with a whole new symbol for that, we're just going to use the Greek letter right there. So let's see here. The z-score also is accounting for the population size or the sample size that we took, and again the square rooting, because as our population size gets bigger, of course our accuracy is going to go up. It's better, but there's diminishing returns for that, so hence the square root. Okay, so let's go ahead and take a look at a few things that I've mentioned. Now, each of these scores right here, you can use for the most part for left or right tests, but they're not going to work. These scores are not going to work for if you have a central test that you need to do. So in the event that you have a significance level different, or you just don't want to memorize all those, when you go to your calculator, you can always get your z-scores using this, and you can use a left or right tail, or, you know, a central if you're doing a central test. Okay, so here is our steps. First of all, we need to find and identify the null and alternative hypothesis, and then identify which one is the claim. Make sure you label which one's the claim. That way you know at the end whether you're going to accept or reject that. Now, I shouldn't have said accept. We can only reject, really. So we're going to actually use the phrase, the evidence does support or the evidence does not support a claim. So we're going to find the critical region using our inverse norms, and then we're either going to accept or reject. Well, not accept. We'll either reject the claim or not reject the claim. Okay. Important to note that we are never going to be 100% sure of what the population is. We can only say whether our sample supports our claim or does not support our claim. We cannot make a truth statement. So it is possible that the evidence, it is actually possible that our sample just was not really representative of the population at all. And when we go to test a claim, we might say, well, the claim's, you know, we might reject it, but that our sample was wrong caused us to have an incorrect conclusion of the population. So it's important that your sample is actually representative of the population. So that, all that being said, let's actually do several of these and try to get used to it. It can get very, very confusing. So the best thing to do is just do a bunch of them. So in this example, Jimmy thinks there are more than 10 ads on Facebook, assuming you're scrolling through a news feed or something. So using a sample of 42 visits to Facebook, he found a mean of 10.5 ads with a standard deviation of 1.6. We're going to test the hypothesis with 1% significance. So my first step is to identify my null hypothesis and my alternative hypothesis. And in this case, notice he's saying that there are more than. So that is a greater than statement. So that would be mu is greater than 10. That's actually an alternative hypothesis. Why? Because it doesn't include an equal. Your alternative hypothesis doesn't equal something. It can be greater, less, or not equal. And this is actually his claim. That's exactly what he said. So our null hypothesis is mu is less than or equal to 10, but he didn't claim that. Okay, so second step, we are going to now find our z-score for the claim. So this is our claim z-score, and our formula is going to be x bar minus mu all over s divided by square root n. S is our sample standard deviation. So we're going to say z is going to be 10.5 minus 10 all over s, that's 1.6, divided by the square root of our sample size, which was 42. And when that's all typed into the calculator, I get a z-score for our hypothesis of 2.025. Okay, so the next thing I'm going to do is I'm going to look at my alternative hypothesis. That's the thing I'm actually going to test and look for a critical region. And since it's greater than, I know I'm going to do a right tail test. So if it's greater, it's a right tail test. So I'm going to draw a rough sketch of my normal distribution. And I'm going to find a z-score using an inverse norm for a 1% significance. And to do that in my calculator, I'm going to go to my stats, and I'm going to put in, or my stats distribution, I'm going to put in my mean is 0. I'm going to put in my standard deviation is 1. I know that's not the actual information in the test, but in the example, but what we're doing is we're trying to use inverse norm to get a z-score that is relative to this 1%. So significant. So I put this in, and I'm going to do my area is going to equal. Now, if I'm doing a right-hand tail test, I'm looking for area right here on the right. So I'm going to do 0.01, and I'm going to select on my menu a right side. And when I do that, I'm going to get a z-score of 2.32. Which means this boundary right here is 2.32. Now, what I'm going to do is I'm going to look, well, where does this z-score fit in to this rough drawing? And it would fit to the left somewhere of this 2.32. It would be 2.025. So my HA, my alternative hypothesis is outside the region. Outside the critical region. So what does this mean? Well, it means that the evidence does not support HA. So what do we conclude? That the evidence now we're going to go back to our claim. So what we're saying is HA isn't in the critical region. So HA we reject. But HA is the claim that Jimmy made. So the evidence does not support Jimmy's claim. At least the evidence that we have in this problem. So it's not necessarily that we're accepting this one, the opposite. It's just the evidence isn't going to support what he has said, or doesn't support it. All right, our next example. Jules thinks that it takes less than 60 minutes to get a full workout at the gym. Using a sample of 128, she found the average workout lasted 58.4 minutes with a standard deviation of 8.9 minutes. Let's test her hypothesis with 10% significance. So first step, just get in this habit. Write it down, even if it's like an online quiz or something. Your null and alternative hypothesis. So let's kind of write down what she has said. It takes less than 60 minutes. So she's saying that the population should do less than 60. So that is our alternative hypothesis. Not because it's what she said, but because there's no equal sign involved, which means the HO, the null hypothesis, is greater than or equal to 60. But the thing that we actually test is this, the alternative hypothesis. So our next step is to find our z-score. So the z-score for when we're doing testing is our sample mean minus our claim divided by our sample standard deviation and divide the square root of our sample size. So we're going to take our sample mean, which is 58.4. We're going to subtract our claim, 60, and we're going to have it over the standard deviation, and divide that by the square root of our sample size. The idea being that if our sample size is quite big, then we're very confident of our results. So when this is all typed in, we should get a z-score of negative 2.0339. Okay, so now that we have our z-score for our claim, we're going to go ahead and identify our test. Now this is a less than, so that tells me I'm going to do a left tail test. So on my calculator, I'm going to use, again, mean 0, standard deviation 1. I'm going to do an area of, well, I want what percent significance? I want a 10% significance. So I'm going to do an area of 0.1. I want to make sure on this last slide, yeah, 0.01. Wanted to make sure I didn't mess up my decimal places on the last one. Okay, so that's our 10%. And we are doing a left tail test. So when we put that in and do our inverse norm, we're going to get out from our calculator negative 1.282. Okay, so when we draw this, here's our sketch, and our critical region is over here. Here's negative 1.28. Okay, and our HA is right in here at negative 2.03. So it's inside the critical region. So what do I say? I say we're inside, HA is inside, and therefore evidence is supporting HA. So the evidence, now HA also happens to be, and I should have identified this, HA also happens to be our claim. So we're going to say that the evidence supports the claim. Now again, emphasizing, I am not saying, and we are not saying, that the evidence proves the claim. This is not proof. Okay, we are not saying that the claim is true. We're just saying that the evidence that we happen to have collected does support what this person said. Okay, in our next example, we have a package label, so on some kind of can or something, says or claims that there are 120 calories in whatever product we're talking about. Using a sample of 38 servings, the FDA found that on average there were 120.6 calories with a standard deviation 2.2. Within 5% significance, what can be said of the label's claim? So what is this company claiming? And this is a pretty bold claim, right? There are 120 calories. So they're saying that the mean is equal to 120. Now, of course, there will be some variability from package to package. So let's take a look here. Using a sample, the first thing we need to do is identify our null hypothesis and our alternative hypothesis. And at this time, we're told the mean is equal to 120. So they have given us the null, and this is our claim, which means our alternative hypothesis, our mean, am I writing mean backwards? Perhaps. I think I am. So our mean, we're saying, is not equal to 120. All right, so now we're going to get our z-score for the claim. So we'll write this formula down. It is slightly different, again, than the regular z-score formula because we're dealing with samples and testing. So our sample mean was 120.6 minus 120. And our sample deviation, 2.2, divided by the square root of our 38. Not a very big sample that they took, right? So when we type that all into our calculator, we should get a z-score of 1.68. All right, so since I'm doing a not equal, this is going to be a central. And when I do my central, I'm going to put in my mean is 1 or 0. My standard deviation is 1. And my area is going to be now, this is going to be where it's a little bit tricky. When we do our central on our calculator, it's actually going to give us, we want these two numbers right here. They're z values. Now, when we do a central, it's going to give us this area right in here. But when we're doing our critical region, we actually want the outside tail ends. So when I do my area, see, these two shaded areas are the 5% significance, which means this area in here is a 95%. So when I do my area, I'm going to put in 0.95. And that's what you'll do for central. Whenever you're doing a central test and you're doing your inverse norm, you're going to have to actually do the opposite of the significance level that you're told. So if you're told 5%, you do 95. If you are told 10%, you'll do 90, and so on. So the two scores that we get when we do that are going to be negative 1.96 and 1.96. So that means this value, negative 1.96, and this value, 1.96. And where is HA? Well, HA is 1.6, which is somewhere over here is our HA. So HA is outside the critical region. So since HA is outside of the critical region, we would reject the HA. So HA is rejected, which means this is okay, at least as far as the evidence is concerned. So we would say the evidence supports the claim. Maybe I'm spelling evidence wrong, but whatever, supports the claim. All right, several more left to do. Okay, manufacturer claims there are 12 ounces in a can of juice. So right away, this is an equal to case, right? So they're saying the mean equals 12. Using a sample of 60 cans, the quality control department found the amount averaged 11.95 ounces with a standard deviation of 1.5 ounces. We're going to test with 1% significance. So first, identify our null and alternative hypothesis. So they said the mean equals 12, and this is their claim. So our alternative is the opposite of that. It's not 12. Next, we find our z-score. So I won't read to you exactly what I'm doing. I'll just write it down. Do be careful how you put this into your calculator. So let's talk about that. Parentheses, 11.95 minus 12. Close your parentheses, divide, now parentheses again. That should be fine. All right, so when we type that in, we do get a z-score for the claim of negative 2.85 or negative 2.582. So now we are going to see this is going to be a central test. Okay, so we want these values right here, and we want to know, this is our critical region. We're going to see where HA is with respect to that. So if we're doing 1% significance, again, our calculator is going to do, when we do our central, it's going to give us this area in here. So if we're doing 1% significance, we're saying 1% represents this area plus this area over here is 1%. That leaves 99%. So our mean when we put this in is going to be 0, standard deviation 1. Our area is this time not going to be 1%. It's going to be 99, so 99%. And we would go ahead, we would put that in central. We want central, and we're going to get two z-scores. We're going to get negative 2.576 and 2.576. Okay, so now that we have those two, we know that we have this right here, this right here, and negative 2.582, well, that's lower. That's like right here. This is HA. So it's in the critical region. HA is inside the critical region, which means we are okay with this statement. We are not okay with this statement. So we're going to actually reject the claim, and we're going to say that evidence does not support the claim. And that's why it's very important at the beginning, because it's possible that if you skip that step of identifying your hypothesis and which one's the claim, that you get all the way to the end, you don't know which thing you are rejecting. So we always are interested in what the claim, whether we're supporting or not supporting the claim. So we're going to say that the evidence does not support the claim. Okay, let's go on. All right, the hospital dining service has heard complaints that the line moves too slowly. The manager assures the hospital that the wait time is 6 minutes or less. The quality control department did a study of 65 customers and found the average wait time is 6.3 minutes with a standard deviation of 1.1. Is the manager correct with 5% significance? So let's go ahead and identify our hypotheses. So what is our hypothesis? Well, it's going to be what the manager says. So the manager has claimed that the wait time is 6 minutes or less. So that would be she or he is saying that is 6 or less. So the mean is less than or equal to 6. So that would be our null hypothesis, which means our alternative hypothesis is the opposite, so it's greater. So in case you're having trouble with opposites, so the opposite of less than is greater than equal to. The opposite of less than equal to is greater than. The opposite of equal is not equal. So these are opposites to each other. So when we identify our claim, the opposite of that, you just take away the equal or add the equal depending. Okay, so our z-score. Now, which one of these was the claim? This is what she claimed or he claimed. So our z-score. Now, this is the z-score for the claim, and I am just going to give it to you. It is 2.199. We do want to keep some accuracy here because these could get really close. So you want to know whether it's in the region or not, critical region. So this is a greater than. So that means I'm going to do a right tail test. So when I go to my calculator, this is what I'm putting in. Now this time it's not a central, so I'm doing a right tail test, which looks like this. So this area right here is the 5%. So our area is 0.05. And when we do that, our inverse norm, when we do that, we're going to get 1.644. Okay, so, well, where's HA? So if this is 1.644, HA is like over here. This is our HA. It's inside the region. It's to the right of it. So it's inside the region. So since it's inside of the region, we are okay with this. We are not okay with that. So, and basically that's what we're saying. If HA is in the region, we're okay with HA. And if HA is not in the region, we're not okay with HA. So we're okay with HA. We're okay with the alternative hypothesis, but our claim was the null hypothesis. So the evidence does not support the claim. Does not support. Hopefully you've gotten a good idea of how to do this. Good luck.